Hello everyone, myself Pawan DA. I'm studying in fifth semester. Today I'm here to discuss the topic about an improved transport layer protocol for wireless sensor networks, which comes under the subject computer network. Abstract. Wireless sensor networks, WSNs, are kind of transportation communication networks having independent nodes that form multiple hop and HOC network to transfer data. In the past few years, various transport control protocols in wireless sensor networks, which is called WSNs, have been developed and proposed in the literature. In this paper, we have analyzed pump slowly, fetch quickly PSFQ protocol and presented an improved transport layer protocol for wireless sensor networks. The improved protocol has been analyzed based on various factors such as average latency and average error tolerance, and it is found that the proposed protocol is better than the PSFQ in terms of these factors. Introduction. Wireless sensor networks. Wireless sensor networks is a self-organized distribution system consisting of one or more basic stations which are usually called sinks, and perhaps tens or thousands of sensor nodes sprinkled in a physical area. Integration of the information sensed through sensors, computations on that, and wireless communication make the sensor node able to gather physical data, process the data, obtain crude information, and report to sinks. The sink can query the sensor nodes for more information. WSNs have several characteristics features. The major focus in this paper is on the design of the transport layer protocol for WSNs. TSN la- transport layer protocols are used to migrate the congestion and reduce packet loss, provide fairness in bandwidth allocation, and to guarantee end-to-end reliability. However, UDP and TCP transport protocols, which are currently used for the internet, cannot be directly implemented for WSNs. For example, UDP does not provide delivery reliability that is often needed for many sensor applications. Nor does it overflow and congestion control that can lead to packet loss and unnecessary energy consumption. For WSNs, various transport layer protocols have been designed to address various issues such as congestion control, reliability, or both. Brief summary of the related protocols is provided in this section. HTCP HTCP Garuda is a reliable downstream data delivery transport protocol for WSNs. It addresses the problem of reliable data transfer from the sink to the sensors. Its design is a loss recovery core infrastructure, the two-stage NAC-based recovery process. RTMC, reliable transport with memory consideration, is inspired from pipe flow method and provides hop by hop retransmission to make sure all of the segments can be received by the sink with 100% reliability. An analysis of PSFQ protocol. PSFQ is a hop by hop downstream transport protocol which is reliable, scalable, and robust. It uses NAC. It uses NAC based loss detection and notification and local retransmission for recovery loss, and is basically designed for retasking reprogramming application which requires 100% packet reliability in the downstream direction. It consists of three operations: pump, fetch, and report operations. The pump operation controls the rate at which the data packets are passed into the network. The fetch operation requests a retransmission of the lost packet from the neighboring nodes. Lastly, the report operation provides a feedback status to the users. This way, it provides 100% packet reliability. Message transmission. The pump operation controls the injection of packets into the network. This operation in controlling the timely distribution of the code segments to all the sensor nodes and providing basic flow control so that the reprogramming operation does not obstruct the regular operations of the sensor network. For doing so, proper rescheduling is required for the data forwarding. PSFQ adopts a simple scheduling scheme which uses the two timers, Tmax and Tmin. The important task of PSFQ is to recover the lost packets very quickly among the immediate neighboring nodes within a controllable time frame. For that, there is a need to provide a time buffer. Tmin gives an opportunity to a node to recover any missing segment before the next segment comes from its upstream neighbors. Since a node must wait at the least before forwarding a packet as a part of the pump operation. Local loss recovery. Sensor node starts PSFQ REST operation to do a local loss recovery. It is started when a sequence number gap in a file's fragments is detected. Channel impairments such as fading conditions are always correlated in time. As a result, loss of number of consecutive data packets occurs, which is called bursty loss, instead of single packet losses. PSFQ combines loss such that the fetch operation deals with a window of lost packets instead of a single packet loss. Sensor node usually has more than one neighbor in dense network. PSFQ allows different segments of lost window to be recovered from different neighbors. Shortcomings of PSFQ. Firstly, shortcomings of PSFQ. Firstly, PSFQ does in sequence forwarding of data packets. For example, if any intermediate node running PSFQ as a transport layer protocol does not have any data packet to and a small all data packet from tree up to last data packet, then this node will not forward any of the data packet to the next sensor node. In the same manner, other nodes also remain idle until they get in sequence data packet. So this increases the time at which last data packet will reach to the target node. Secondly, there are some drawbacks into the pump and repair operations of PSFQ. Whenever in sequence data packet arrives, it waits for the random time between tmin and tmax for forwarding the data packet. Node does this waiting by setting a schedule. Finally, in PSFQ, same thing as above happens while repairing the data packets. Repairing of a particular data packet will be failed if radio component is busy, as PSFQ does not reschedule the data packet to forward it ahead. Improved transport protocol, out of ordering forwarding. As we have seen that in sequence forwarding results in an unnecessary delay, we are proposing out of order forwarding of data packets. We have implemented it as follows. Whenever data packets arrives at the sensor node, it checks whether it is a duplicate or non-duplicate data packet. If it is a duplicate data packet, then it will be discarded. Otherwise, node will store the data packet into its data cache and schedule it to forward it ahead. Now, this is a comparison of the average delivery ratio of PSFQ as function of network size. Conclusion. We have initially presented the various protocols available for transport layer in wireless sensor networks. After that, we have presented overview of PSFQ protocol. We have provided some alternations to improve PSFQ efficiency. We have also shown the performance and analysis of the original PSFQ and improved PSFQ. It has been shown that improved protocol works better than the original PSFQ in terms of error tolerance and average latency. We have evaluated both PSFQ and improved PSFQ using simulation. We have found that improved PSFQ has good error tolerance and delivery. Thank you.